Hello, RightsCon, and welcome to the tech demo about the Censored Planet Dashboard, which is an online tool that lets you explore and understand internet censorship practices through data collected by the Censored Planet Observatory. My name is Ramsundar Raman, and I'm a PhD candidate working on Censored Planet at the University of Michigan. And I'm giving this tech demo with Sarah LaPlante, who is a software engineer working at Google Jigsaw. So, what is Censored Planet? Censored Planet runs a network observatory which uses remote measurements to detect network interference. By remote measurements, we mean that Censored Planet sends website reachability measurements to tens of thousands of public infrastructural machines on the internet, which are in different countries, and uses the responses from these machines to infer censorship or other forms of interference. By doing these remote measurements, we don't have to rely on having a presence inside a country of interest, such as asking for volunteers to run measurements or getting access to accessible vantage points. This allows us to collect measurements very regularly and obtain a comprehensive picture of censorship in a large number of countries and across large time spans. We've been collecting data on a variety of censorship techniques in over 200 countries since 2018. To learn more about our measurement techniques, you can visit the publications on our website. These measurements produce a huge volume of data, which we've been working to make more accessible in a dashboard format. The dashboard is currently in beta, but you can contact us to get access to the dashboard at the link above. Sarah is going to start us off with a demo on how to use the Sensor Planet dashboard. Please add any questions you may have to the RightsCon chat box. We'll be live to answer them.
Hey RightsCon, this is Sarah LaPlante. I'm going to be walking you through an example of using the Censored Planet dashboard in Belarus. So this is the initial view that you'll see when you're dropped into the dashboard. And we're in the HTTPS analysis tab. So we're looking at tests of HTTPS connections. And the country that we're looking at is Belarus. So I'm actually going to go way back in time to August of 2020, which is when Belarus was having a contested election. So it's an interesting time period to look at. And the way this dashboard works is these filters at the top let you filter down by various test criteria. And then this pivot table shows domains on one side, and then it shows networks up at the top and subnetworks under those networks. And then these columns show the number of tests made for that domain in that network. And this orange column is the percentage of those tests that had unexpected results, where we saw something that we wouldn't expect to see in a normal connection. And it bubbles up to the top sites that have a lot of unexpected results. So one thing that we're seeing here is Siphon, which is a known censorship circumvention tool. So let's filter down only to Siphon. When we filter down only to Siphon, we can go down to this outcome townline, which shows us the results from tests over time. And we can see these green results, which are expected connections, and also these orange results, which are timeouts, and these blue results, which are TCP resets. So both of these are ways that HTTPS connections could be blocked in a country. But this has sort of a mix of different results, which is a little bit confusing. So one thing that people often want when they ask about censorship in a country is sort of a binary yes-no answer of like, it's blocked in the country, not blocked in the country. But the internet is a network of networks, and so you can have different things happening even within a single country. So we can look at this network tab here, and one thing that we're seeing is that some of these networks seem to have a lot of green results, whereas some of them have more resets and timeouts. So we're going to go up and filter down to just one network at a time to maybe get a clearer picture of what's happening. And when we do that, we see initially there were expected results. And then sometime around August 9, which is when the elections were happening in the country, Siphon goes to suddenly experiencing a lot of timeouts. And then between the 21st and the 24th, it goes to experiencing a lot of resets. So what we seem to be seeing here is Siphon having expected behavior, then switching to getting a lot of timeouts, and then switching to a different behavior over time, which is a very interesting result. And actually, if we go filter out into the future and look at a longer time period, you can see that these resets actually persisted. And if you go look at the dashboard now, you also see that these resets are happening currently for Siphon in this network. So now I'm going to hand you back over to Ram to look at a more topical example.
Hi again. Now let's look at a more recent example, that of social media blocking in Russia over the past few months, which I'm sure a lot of you here are interested in. So I've already selected Russia as the country that we're interested in exploring. And we can see from our pivot table here that facebook.com bubbles up as one of the domains that faces a lot of blocking. So to explore this further, I'm going to go to our domain tab and select facebook.com as the domain we want to filter down to. I'm also going to set a start date back to February 15, 2022, which is before the start date of the Russian invasion into Ukraine. Now that I've set all of these filters, let's go down and look at our outcome timeline chart. We can see that until March 7th or so, there is almost no blocking of Facebook. And after that period, we start seeing increased anomalies for Facebook. This is around the time when Roskomnadzor added Facebook.com to its list of blocked websites. We see that not all of the ISPs block Facebook, and this is because Russia is a very complicated case, because Russia has a lot of different ISPs, and each ISP implements its blocking differently. Let's filter down to one of the big ASs that sees blocking here, which is Wimpelcom. And once we filter down to this AS, we can see the pattern very clearly of almost no blocking up to March 15th or so, and then timeouts after this period. Now that we've seen how Facebook.com behaves, we can also go back and see how other social media domains behave by removing this filter for Facebook.com and then selecting the social media and networking category in our list of domain categories. Once we've selected this category, we can see from our pivot table that in Wimpelcom, other domains such as Twitter.com, Instagram.com, and LinkedIn.com also face blocking in the recent months. Now, I'll give the floor back to Sarah to talk about exploring internet censorship in Iran.
Hey again, this is Sarah. I'm going to be walking you through another example looking at Iran. So we're still in the HTTPS tab, and now we're looking at Iran. And as you might imagine, there's a lot of websites blocked in Iran, but there are so many websites that it's actually kind of hard to tell what might be interesting. So let's use this site category filter and filter down to just news websites. And when we filter down to news websites, we see some websites that look more interesting. And if we look at the outcome tab, we see a lot of different results, including some results that are expected and some that are unexpected because we're looking at so many different websites. So let's filter down to just the BBC to pick one website. And when we filter down to BBC, we see only unexpected results. So we're getting some timeouts and some resets and this one empty result. And interestingly, if we look at the outcomes per network, it seems like most of these networks are using timeouts as their blocking mechanism, but two networks, Afternet and Aslan Paradox, are using resets as their blocking mechanism. So in HTTPS blocking, timeouts and resets are what we commonly see, but they can sometimes be ambiguous because they can also happen due to normal network conditions like network congestion, but because the connection is encrypted, that's the only way for a censor to insert something that causes the connection to fail. But if we go over to this HTTP tab, HTTP is unencrypted. So with HTTP, you can actually insert full readable content into the connection. Let's look at BBC again. And if we go down to BBC, we're still seeing some reset results, but also now we're seeing these block page results. So Censored Planet has categorized a lot of known block pages that people see on HTTP connections, and they publish them on GitHub. And so in this case, we're seeing this national block page, and then we're also seeing a different national block page spread out over time. And if I look in the network results, I see this gray block page, which is national block page 1, but I don't see this red block page. But interestingly, if I go look and I pick just Afternet and Aslan Paradox that we were looking at before, and come back down here, then I see this red block page. So it seems like most of the networks that were using timeouts were also using that block page number 1. And then the two networks that we saw in HTTPS using resets are also using this different block page. So what we seem to be seeing here are two different systems that exist within Iran that are used by different sets of networks to accomplish censorship. So I hope those examples were helpful. We will be in the chat after this presentation to answer your questions, and I'll see you there. Thank you very much.